Independent probability. In a group of 150 people, 48 have green eyes, 15 have blue eyes, and 87 have brown eyes. What is the probability that a person chosen at random from this group has green eyes? So to find that probability, we're going to do the total number of people that have green eyes over the total number of people in the group. And you can do this division on a calculator. I'm just going to do it mentally. I'm going to divide both of these by 3 to simplify, and I get 16 over 50, which I would then convert to 32 over 100, which is 0.32 or 32%. Now, this step that I did right here and right here, you don't have to do that step. If you have a calculator handy, you can just do 48 divided by 150, and you'll get this. And then 0.32 or 32 hundredths is the same thing as 32%. So it just depends on what form the answer is given, whether you're going to need it as a decimal or as a percent. Okay, sophomores and juniors at Pompano Beach High School were surveyed to see if they play an instrument, and the data is displayed in the table below. So here we have sophomores and juniors, and out of the sophomores, this many students play an instrument and this many don't, and out of the juniors, this many students play an instrument and this many don't. If a student is chosen at random from this group, what are the chances of choosing a student who plays an instrument and is a junior? So plays an instrument and is a junior means that we're looking for the intersection of that row and column. So plays an instrument would be here, right? Is a junior would be here. So the intersection would be 85. Now that's the number of students. 85 students play an instrument and are juniors. But we want the chances or the probability. So to get that, we have to put 85 over the total number of students surveyed. So that means I have to add 64, 183, 85, and 168 together. When I add those 4 numbers together, I get 500. Then I can reduce 85 over 500 to 17 over 100, which is 17 hundredths as a decimal, which is also 17%. And again, it depends on how the answer choice is written, whether you need it as a decimal or as a percent. And just like I said before, you don't have to do this step. You can go straight from here and do 85 divided by 500 and get 17 hundredths, get 0.17 as a decimal on your calculator. And then you can convert that to a percent if needed. Okay, Olivia's teachers assign homework independently from each other. Now, Olivia knows that there's a 75% chance that she'll have physics homework and a 40% chance that she'll have math homework. What's the probability she will not have physics or math homework tonight? So in the previous question, we were looking for the probability that a student plays an instrument and is a junior. So we were looking for the intersection, for the people that fall into both of these categories. In this question, notice it's the word or. When you see the word or, that means that we're adding them together. We're combining them by adding. So let's figure out the chances that Olivia does not have physics homework. And the probability that she does not have physics homework would be what we call the complement of this number. So if there's a 75% chance that she does have physics homework, then that means there would be a 25% chance that she doesn't, or 0.25. Same thing for math. What's the probability that she will not have math homework? Well, if there's a 40% chance that she will, then that means 100 minus 40 would give us a 60% chance that she won't. So what's the probability that she will not have physics or math homework tonight? Remember, when you see the word or, that means add. We're going to add these two together, and we get 0.85. So there is an 85% chance that she won't have physics or math homework tonight. Okay, 240 members of a gym were surveyed about their sport, and the results are displayed in the Venn diagram below. If a member is randomly selected from the group, what's the probability that they are in both gymnastics and cheerleading? Round your answer to the nearest whole percent. I know I use this example a lot of gymnasts and cheerleaders, but there's a lot of overlap usually between these two sports. So let's look for what would go here in this question mark spot. We know that there's 240 members total who were surveyed. And the ones we have results for are 73 from the gymnast circle, 161 from the cheerleaders, and 2 that are neither. And when you add that up, you get 236. So if 240 were surveyed and we have results for 236 of them, then that leaves 4 students or 4 gym members to go in this little inside section. So we know that this is 4. Now we have to figure out the probability. So the probability of that they're going to be in this intersection is going to be the amount of people in the intersection, which is 4, over the total number of people in the gym. So 4 out of 240 is, well, we can reduce and say that's 1 out of 60. And then the decimal for that, and pull out my handy dandy calculator, is 0.01666666. So let me change that. 0.016 repeating. So if we were rounding to the nearest percent, or the nearest, let's say we're rounding to the nearest percent, it would be 1.6, so it would round to 2%. Or you may be asked to round it to the hundredths place. In that case, it would be 1.67%. Okay, and the last question. A two-way frequency table shows gray hair in people over 35 and under, oh, this is supposed to say over 30 and under 30. So in our chart, we have, this is the people under 30. So there's 70 people total under the age of 30. Over the age of 30, there were 30 people that were surveyed. And there's 100 total. Then for gray hair, there were 30 people with gray hair that were surveyed. And for no gray hair, there were 70 people with no gray hair that were surveyed. So it says, based on this data, are gray hair and being over 30 independent events? Well, in order for them to be independent, this is what we have to have happen. We have to have that the probability of being gray times the probability of being over 30 is equal to their intersection. So let's take that piece by piece. Let's find this part first. What is the probability that someone in the survey has gray hair? Well, there were 30 people with gray hair, and there were 100 people surveyed total. So the probability that someone is gray is 30 over 100, or 0.30. What is the probability that someone is over the age of 30? Well, actually, let me do this in a different color. Over the age of 30, there are 30 people surveyed that are over the age of 30. So 30 out of 100 is, again, 0.30, right? 30 hundredths. Or you could if you don't feel comfortable converting from 30/100ths the fraction to 30/100ths the decimal, you could do 30 divided by 100 and you'll get the same thing. So now let's look for the intersection. The intersection of these two is where the row and the column cross. So the gray hair row is right here, and the over 30 column is right here. So this is their intersection. And this intersection is 9 out of 100, which is 0.09. So now what we have to check is if this side is in fact equal to this side. So does 0.30 times 0.30 equal 0.09? And it does. They are equal. So since they are equal, we can say that these are independent events. If they were not equal, then we can't say that. But since the product is equal to the intersection, right? Product of each is equal to the intersection, we can say with certainty that they are independent events.